Microgeneration technologies and systems enable individual households, businesses, and community organizations to produce their own heat and electricity on site. These technologies are low carbon and offer protection against rising energy prices. Microgeneration technologies can also help the government to achieve its renewable energy target of 15% by 2020 and safeguard our environment by reducing carbon emissions. The MicropowerCouncil represents companies and organizations active in the microgeneration sector and campaigns on behalf of members for a favorable policy and regulatory environment. Dave Sowden is Chief Executive of the MicropowerCouncil.
I think we need all of the solutions in the sustainable energy mix if we are to meet the government's targets, and provided we have all those, they're absolutely achievable.
There are many different types of microgeneration technology with something to suit almost every type of home and building. These include heat pumps, micro-wind, micro-CHP and biomass, as well as two different types of solar technologies, photovoltaic systems that produce electricity and solar thermal systems to provide hot water and even space heating.
Mark Group is one of the UK's largest installer of home energy efficiency measures. Every week we make around about 6,000 homes more energy efficient by installing things like home insulation, but also microgeneration technologies as well. Things like solar thermal, solar PV, heat pumps or small-scale wind turbines. Now recently we've been exporting our expertise into new territories and have set up operations in Australia and the US. So it's a really exciting time for Mark Group. Mark Group installs all shapes and sizes of solar thermal system, from perhaps a single panel on a small dwelling up to dozens of panels on something like a care home or perhaps a leisure centre. The number of properties we do ranges in the thousands every year, but we think the potential is actually in the tens of thousands. It's perhaps a little bit too early to tell just how much of a role solar thermal will play in helping government reach its renewable energy targets, but I think it's got tremendous potential. If with a correct policy framework behind it, I think solar thermal in the UK could be a real winner in terms of creating jobs, in terms of reducing carbon emissions and improving our energy security position. There are several ways in which a customer can benefit from a solar thermal installation. Firstly, of course, there's the benefit to their domestic hot water. Around about 50 to 70% of a typical household's domestic hot water requirement can be served by a solar thermal system. Then there's the potential enhancement to the value of the property, or at least how easy that property is to sell. Common sense would say if you have two identical properties and one has a very good, well-installed, well-designed, well-maintained solar thermal system with the right guarantees, that house is surely going to be worth more. And finally, of course, there's the renewable heat incentive. So there are direct financial benefits in some cases for this technology. I think the future for microgeneration in this country is bright. I think that has a huge role to play as part of an integrated renewable and wider energy policy. I think its potential to contribute towards energy security, carbon reduction, and perhaps in the case of microgeneration, the creation of thousands of green, sustainable jobs is tremendous.
Solar thermal is being installed in homes all across the UK. Paul Hawksworth is one customer with first-hand experience of the technology, having had it installed on his family home.
I'd recommend this system to anybody really, mainly for its flexibility. What I've got is a 500 litre tank here, which is being kind of supplied from my solar panels on the roof. And what'll happen is, once it gets above 50 degrees centigrade, this will feed my shower or whatever hot water I need. If it drops below that, then effectively it cuts out and my combination boiler kicks in. So you get the best of both worlds, and it's like a partnership between the two systems. Also, overnight, which is a nice little thing to have, is an immersion rod in the bottom. So what it can actually do then is use economy 7 electricity to actually charge the system overnight, which kind of uses any latency which is in there to get you above that 50 degrees again. Effectively, I've got 3 systems here, all working in one, which gives me a nice warm hot shower in the morning, primarily solar fed. The overall install took around about 2 days, from sticking up the scaffolding and then installing the panels into the roof. The guys that did it were really professional. They sheeted up the stairs and kept it really clean. And also, of course, when we left the site, they explained to us how it worked and how it all held together. Yes, I'd recommend this to anybody really. The way it works, it's got to work in association with what you've got. It's not just something you can sit into a system and think it's going to provide everything. It's actually got to work alongside your current gas, electricity. So it's an excellent system that works within that flexibility.
Microgeneration isn't just about homes either. It can also provide energy on site for businesses, community buildings and public facilities. Microgeneration can include anything up to around 50 kilowatts for electricity and 45 kilowatts thermal for heat, although community and light commercial installations fall within its broader scope. Eric Reynolds chose solar PV for his mixed-use development, Trinity Buoy Wharf.
This particular project is in two parts. One is to replace the roof on a building that was built in 1860. Interesting enough, it's called the Electrician's Workshop. That was its original industrial name. It's now full of artists, it's studios. The roof was leaking, so we needed to do something about that. And fortunately, there is now a package where you can put a new roof system and a PV system together. We moved fairly swiftly. We started the decision-making process was in December of last year, and here we are in March, and with any luck we should have a functioning system with about 500 square meters of PVs, producing 20 kilowatts of electricity, particularly on a day like today. And so the whole process has been quite swift, and we hope effective in both waterproofing and future-proofing. Now, it's possible to be much more efficient and realistic. For example, these PVs that we're fitting to our roof now. We could just have resurfaced the roof, but obviously because Kingspan makes it possible now to put it together as a sensible package, we can not only be seen to be green, because people will see that big roof, but actually be green.
The feed-in tariff, introduced in April 2010, has begun to transform the UK market for solar PV, just as it has for other European countries. There is great potential for decentralised generation of electricity in the UK, but regulatory stability and the right level of support will be crucial as we move towards a genuine mass market for low-carbon, on-site heat and power. Heat pumps are another type of microgeneration technology that can use heat in the air and ground to provide warmth in homes and buildings.
I'm responsible within Mitsubishi Electric for the introduction of renewable low-carbon domestic heating products into the UK, and therefore I've put an air source heat pump into my own property, so I can understand how the technology works within a domestic environment.
How a heat pump works is it takes all the energy that's in the air that's put in here every day by the sun, and via this fan that's running, it pulls the air round the back, and within the heat pump there is a liquid. The liquid absorbs all the heat that's coming through from the air and it turns it into a gas. That gas then goes through an electric pump that's also in the heat pump that turns it into a high pressure gas, and with being high pressure it also becomes high temperature. That high temperature gas is then fed into the water, which via these pipes then just goes into your house as hot water as a normal traditional heating system would do. And it just continually does that all the time. Another important thing to remember with air source heat pumps is not just on a beautiful day like today it will work, even when there's frost on the ground, minus 15, 20 degrees, it will still continue to work and produce enough heat for your home, providing it's been correctly sized.
Government policy and philosophy in kickstarting the microgeneration industry is absolutely crucial in my opinion. I mean, we've seen how the government with the feed-in tariff has really got the microgeneration, electrical generation industry going in the last 12 months. So that's very, very important. But I think also what's equally important is the way the government has to get behind the whole of microgeneration. The benefits for Mitsubishi Electric to being a member of the MicropowerCouncil is that we can come together with the rest of industry and we can put our case together and ask the MicropowerCouncil to put that to government, and they can also act as not just also the facilitator, but make sure that we are actually speaking as an industry with a common coherent message.
Finally, the microgeneration sector is home to numerous innovation companies, developing the technologies that will enable individual citizens to take control of their energy future. In years to come, fuel cell micro-combined heat and power is just one example.
Ceres Power started off in the labs of Imperial College as a material science research activity. And then back in 2001, the patented idea was launched in the form of a new business, Ceres Power. Over the last 10 years, we've turned an idea into a technology, into a product which we've now got customers really interested in. So it's been quite a journey. Ceres Power's product is a so-called combined heat and power unit that takes in gas but turns into electricity without burning it through an electrochemical process based on something called a fuel cell. That takes air, oxygen from the air, hydrogen from the fuel, and turns into electricity directly. Heat's given off as a byproduct. That heat goes into the home central heating system and hot water system, so one energy input becomes 3 energy outputs, saving energy and saving money. Ceres Power decided to join the MicropowerCouncil to be in a like-minded community of companies involved in microgeneration. It's important when any new industry gets going that you get together to speak with one loud voice to a range of stakeholders, whether that's investors, government officials, the media, suppliers, customers. It's important that people realize this industry is coming of age and going to be growing fast, and it's important that companies get together to speak with that one voice. There are a number of specific policy measures, either existing or future, which are going to be key to really making sure this industry is a really great success. The highest level policy is around encouraging low carbon, specifically low carbon technology. If government misses the boat on that, there's a whole sector that's going to go away. If the government gets it right, a number of low carbon innovations, including small scale and large scale, will be deployed. If you're talking about microgeneration specifically, things like the feed-in tariff, a financial incentive for encouraging consumers to buy and use a product that generates power at home, is a really important mechanism. That will really get people engaged at the home with their own energy needs. Without that, you're relying on a slower, more painful process to get adoption rolling.
A flourishing market for microgeneration will lead to growth and new employment and training opportunities. Companies such as Ceres Power are always on the lookout for individuals who can help them thrive.
I think the jobs market at the moment is very difficult, especially for graduates, especially for young people at the moment, those without experience. Many of my peers are still struggling to find jobs within engineering and other sectors, so all the sectors have been hit quite hard, I think. I was quite fortunate in being able to find a job at Ceres Power at the time.
The MicropowerCouncil represents companies and organisations active in the microgeneration sector and campaigns on behalf of members for a favourable policy and regulatory environment. For Dave Sowden, Chief Executive of the MicropowerCouncil, policy and regulation is key to the success of the microgeneration sector.
I think what's fundamentally important if government wants the industry's help in meeting its carbon and renewables targets is that it understands how business operates, and that often is about the forensic details of how the policies are implemented and what's going to make a difference to successful businesses. And for that, the key is long-term regulatory stability as well as ambitious incentives. And that engagement between business and government is something that we take extremely seriously. We spend a lot of time with our members understanding what makes them tick commercially. We spend a lot of time with civil servants and with politicians trying to understand their objectives, and we see our role as marrying the two together so that we have a policy framework that really works very effectively for the business sector in the microgeneration industry. I think it's very important that government sets a long-term, stable regulatory framework that has a package of generous financial incentives which motivate people to take up these technologies, that engages the public and sees the maximum possible deployment of these technologies in the built environment so that we get the citizen engagement, we get businesses engaged in this agenda. We use microgeneration to help sell the message of the whole sustainability agenda. And if we have a long-term, stable regulatory framework with a generous package of financial incentives that achieves that, then just sit back and watch this industry fly.